Hey, how's it going, everyone? I just want to do a video on image visualization. So I just came off of Jose's hangout today, and I just kind of caught it at the tail end. Definitely not an expert in it, and I have a feeling not many people are, just because of the amount of nonlinearities, how multivariable this thing is. And I've done a video on that in the past, and it's very, very complicated because of the atmosphere, and we're talking about large distances, optics. If it's the eye, the human brain is involved, and all these kind of things. And so very, very complicated topic, but I'll just give sort of the intuition, at least from a very, very, first step, in this debate, and broadly speaking, where the two sides stand on what they would expect to see if the Earth were flat. And so that's kind of, where I'll begin, and then just give people some intuition, at least, of what people are arguing. So I call this image visualization basics. And so basically, this is what, is from a high level is what's happening, is that people are presenting images with a lot of times water blocking the bottom of something, or completely covering or obstructing something totally, and then saying that that's Earth curve. And so the argument that people would have is like, if the Earth were flat, obviously that would not happen. You would still be able to see some or all of those images that are being blocked by the water. And so just let's look at the situation on a flat Earth. Let's say that the black line at the bottom is the ground and it's perfectly flat. And then we have a person, an observer, on the far left looking at a tall pole. And let's say that the top of the pole has a red marking, a red dot, very distinguishable. And then the bottom has a yellow dot. So basically what the ball earthers would say is that as this pole moves further and further away, we all would agree that it gets smaller and smaller, and obviously less of the details of that pole are visible to the person as it gets further away. That's not in question on either side. However, the ball earthers would argue that that yellow dot should always remain visible as long as you can see the red dot at the top. So as long as you can see the red dot by itself, the yellow dot should also be visible. And if they're ever confused, the both of them need to be sort of blended together. So whatever the combination of red and yellow would be, that's what would be seen. But their argument is that anytime, again, you see the red, you should always be able to see the yellow on a flat surface. And so just kind of walking through this, my defense of this would be that, so like I said, the ballers would expect red, yellow, and black to always be visible, quote unquote, at the same time, or else have a perfect blend of those three colors. So they would say that on a flat surface, the red top, the yellow bottom, and then the ground should always be visible. If not, they're all blended together perfectly. And so what I would argue is that, and this, at least from an intuitive perspective, makes a lot of sense, is that, to me, like, the taller that pole is, the further away that it is, the top of it will always sort of be visible, for many, many miles. And we see that. No one would argue that, if the pole is high enough, you'll always be able to see the top, for large distances. So my point is that the yellow and the black base will always be the first point of confusion. And so what I would say is that because the ground just visually has sort of a consistency, and then from where the person's standing all the way to the base of that pole, there is sort of a continuity, and our eye and our brain is sort of continually able to extrapolate that surface, in the horizon well. And then so what I would say is that the yellow base gets confused or clouded, intermingled and overtaken by the black ground first. And so that, to me, is the initial sort of what some people, I believe, would call like a zone of confusion, where the ground is actually sort of, quote unquote, easier on the eyes, and overtakes the yellow base first. And then if that pole is moved further and further away, then the red top of the pole will get confused now with with the black line or the ground or water, whatever is the case. And so that's really the fundamental difference that ballers would say, is that they're expecting those three things, the red, yellow, and black, to sort of all be visible at the same time. And to me, that doesn't make intuitive sense. It doesn't make sense at all, because the red should clearly always have sort of the easiest thing to view for our eyes, because again, it's elevated, and that's not question. But to me, the yellow and the black, the yellow bottom and then the ground being confused, and the ground overtaking at some point, to me, again, is very, very logical, and to me makes a lot of sense. And so flat earthers will essentially have the stance that the black ground will win against the yellow at some point, because it is easier to see than the yellow base. And then again, if you move that pole like far enough away, really all three things will collapse into one point, and then they'll all be sort of confused or not visible, and just collapse into the horizon. And so that's really the stance. I think our stance as flat earthers is very, very logical and rational. I think again, it makes perfect sense to me that the ground would overtake the base at some point, because our eye is able to see the beginning of the ground right by our feet, and then we're able to extrapolate that line out, and then just by sort of continuity, that is visually easier to see and discern that structure. And then the base of the pole is just going to get confused or blended into that structure at some point. And so so fundamentally, like visually, this is what the ballers again would say, is that red, yellow, and black should always be acting sort of independently and visible, no matter what distance. And again, if they do collapse, they're all going to collapse sort of uniformly. And then, however, we take the stance that at some point very, very far in the distance, that yellow base is going to get overtaken by the earth, by the ground or surface or water, just because the ground is again easier on the eyes, and that type of thing. So it's very subtle, what the difference is. But to me, again, it's just kind of thinking about this, picturing this type of an experiment in my head with a pole with a red top and a yellow base, and then just imagining it getting moved away from me on a flat surface. I would expect to see this. I would expect to see this scenario over this scenario that the ballers think would happen over a flat surface. I do believe strongly, that yellow base would just eventually just get muddied and confused and lost into the ground. And if you move that pole even further, then that red point would as well. And then it would be in that sequence. It would be yellow gone first, then black, yellow first, then red, and then black. And ballers would say it's all three at the same time. And so, I think we have a solid stance. I think there's a lot of mathematics involved to model this perfectly, and I don't think anyone has the skills or the ability to do that in a way that I don't know. I just don't think anybody, unless they have like sort of a commercial reason to do it, a financial incentive to do that type of modeling, that it would be possible, and to be able to like then use that in all the different scenarios that people are taking these images and all the different atmospheric conditions. And so, I'm not opposed to obviously like those kind of discussions. I think they're good, but I just think, again, like the amount of nonlinearities in these kind of arguments is just overwhelming, and it's just they could be a feather in the cap to both sides. And I think, to me, it's not a good place for a rigorous proof or a test, and or at least it would need to have other parameters, other things to help pin it down, like using multiple cameras at the same time, or cameras coupled with drones, or cameras coupled with like a side angle test or observation simultaneous, and all these kind of things. Because again, we're dealing with such a multivariable problem. Shooting it just from one direction down the line is not enough. There's not enough data points there to make a conclusion on the shape of the Earth. But purely from sort of intuitive perspective, I feel very comfortable with the stance that yellow base is going to get lost into the ground first, and then the red top, and then the ground will get confused next. But ultimately, always, the ground's always going to win. Just because, again, that is the easiest thing that our eye can latch onto, and it's just extrapolating from the ground that we're standing on, and that line will at some point meet the horizon, and then the idea is that there's the most sort of support. It's like the horizon or the sky is there, and it's vast, and then the ground that we stand on is extending, and it's vast. So those two things were always going to win. No one will argue that. They're always going to be the thing that the eye will have as a sort of last resort to look at. And then in the meantime, while this pole is moving left to right, the eye can settle on those things. But at some point, the sky and then the ground are always going to quote unquote win, and then our eye will always have those two things at the end of the day to settle on. But I think again, like I said, just to summarize, the yellow base getting muddied and confused into the ground first, and then the red top, and then getting confused into the ground, and then the ground and the sky, win at the end of the day. And that's a sequence of events. Hope everyone's doing well. Bye.